welcome back.
Hi, everybody.
We're at 4.8. It's the end of chapter 4.
Yay!
Finally.
Seems like it's taken forever.
All we're going to do today is use all of our trig functions and inverse functions to solve problems.
Is that word problems?
Word problems.
Yes!
Lots of word problems.
All
We
right.
got some easy problems, some medium problems, some hard problems.
No, really, just we have easy and hard.
Yeah, that's what we did on the worksheet,
We
on
did.
the notes.
But in class, we'll have medium.
Yeah, that'll be nice.
Yeah. Okay, you're up.
All right, so first thing we got to do is we're going to try drawing pictures of this. Now, we have this statement here. It says the most important part of these things is to try and draw an accurate, detailed picture. So on our first one, we went ahead and drew one for you. Okay, that's pretty accurate. Never mind. Okay, I gave Mrs. Kozlova
I am
a hard
sure
time.
the plane is as big as the person.
This little guy will not fit in that plane. I'm sorry, but that's okay.
It's a perspective thing.
There are two vocabulary words we should cover before we start some of these problems. One of them is angle of elevation, and the other is the angle of depression. Both of them are measured from a horizontal line. You've got to think of this as you walking around looking straight ahead. When you're depressed, you look down. When you're excited, you look up. I don't know which way you look up when you're excited, but angle of elevation, people don't seem to screw up. If you are looking horizontally, you look upward to elevate. But if there's a guy in this plane, let's see, his head's right there, and he's looking this way, and he's depressed, he looks down from the horizontal. Everybody wants to make the angle of depression somewhere else.
I don't know where
They put it in weird places. So let's just try to make sure we get the angle of depression correct.
So we could think that the angle that the man in the airplane looks down is the same as the angle the man on ground looks up.
Yes, forgot that part. They're actually equal, aren't they?
They are.
That's going to come in handy later. You remember your geometry? These are called alternate interior angles.
Yes.
If two parallel lines are cut by a transversal. Never mind. Okay. So, first problem. From a boat on a lake, the angle of elevation to the top of a cliff is 20 degrees, 42 minutes. If the base of the cliff is 1,394 feet from the boat, how high is the cliff? Okay, so...
47 and a half. No?
You just know that?
I just, when in doubt, say 47 and a half.
Oh my goodness. All right, so we have a boat on a lake. So here's the lake.
I like how you made it blue.
And then we have a cliff. And there's some weird person up there, I guess. And then we have this boat. We're going to have a red boat because that's just what I wanted. And I can't draw other boats, so it's just a sailboat every time I draw a boat. All right, so the base of the cliff is 1,394 feet from the boat. So this distance here is 1,394 feet. We're interested in how high the cliff is, so we need a variable. Let's call it x for lack of imagination. You can call it h for height. And what we have when we do this is we basically have a right triangle with a watery edge and a cliff edge, but basically we have a right triangle. The angle of elevation, again pretending like this person's sitting in the water, I guess, but the angle of elevation is here, okay? And it is 20 degrees, 42 minutes. And now we have our picture.
That's just a right triangle.
It's just a right triangle.
Can't we just use SOHCAHTOA?
We're going to use SOHCAHTOA.
Nice.
Forgot how to spell that. There you go. All right. So what the heck does SOHCAHTOA help me with? Well, I have an angle. I have a side that is adjacent to it. And I have a side that I'm solving for that is opposite of my angle. So which one of these am I going to use?
Opposite adjacent is tangent.
Tangent. There we go. So we're going to take the tangent of our angle, which is 20 degrees, 42 minutes, which, by the way, we can just type into our calculator exactly the way it looks, is opposite
X
over adjacent, which is
1,394.
there we go. All right, well, on the left side of this, we basically have a numeric value that our calculator will spit out. So how do I solve for x?
Multiply by the denominator.
Multiply both sides by 1,394, which leaves me with an x on this side and a 1,394 times the tangent of 20 degrees, 42 minutes. And I pull out my calculator and type it all in.
And you get 526.749.
Approximately my height in feet.
Except for it said to round to the nearest foot.
Oh, yeah, try reading the problem. Something that,
So how about 527?
527 feet. Yay. I like
That's
drawing
beautiful.
boxes. Isn't that great?
You make fun of my drawing.
Alrighty. It was working well till that board got whacked out on the bottom.
Great. And then you give me the board that's all messed up.
Just don't write on the bottom corner.
Okay, no bottom corner.
Alright, good luck with this problem.
All right, so we went from really easy to really hard. So this is as hard as it will get. Okay?
Promise?
Promise. Well, I don't know. You made the worksheet. What do you think?
I think it's true.
Okay. The bearings, so bearing is measured from
The north.
the north, okay, of 2 ramps on the shore from a boat. So we are measuring from the boat
To the shore.
to the shore.
It's
Okay?
like diagramming a sentence.
Yes. And then they give me 2 angles because there are 2 ramps. Okay, so what do we need? We need a shore. My
Yep.
shore is going to be green.
It's full of algae.
It is. And it's going to have a ramp here, we'll call it A, and a ramp here, we'll call it ramp B. And then we have a boat. Was that a red boat you had, Mr.
I had a
Lucky?
red boat.
Okay, I'll make a red boat. I don't tend towards red because I wear it all the time, but that's okay. So we've got this red boat, and we're going to do bearings measured from north, okay? So from the boat to the first point, and the boat to the second point, is going to make a little triangle like this. We're going to make it a little prettier here in a minute, if that's the right word.
Prettier?
Prettier. Okay, so which angle, let's see, the bearings, so we've got 2 angles, to the 2 ramps on the shore are 115 degrees and 123 degrees. So, from the north around to here is going to be what?
115. 'Cause that's the smaller of the two.
15, because that's the smaller and I got there first. And from the north around to there is going to be
123 degrees.
123 degrees. Now, if we put nothing else in our picture so far, and we think about the fact that this bearing line, this north-south line, and this north-south shore should be parallel, then what we can also do is we can also talk about alternate interior angles, and this 115 with this transversal really belongs right there. So far, so good?
So far.
Except for it doesn't really look like 115, but it is. So that means that the other angle, 123, is going to be right here, because it has its own transversal right there.
And you all wondered where you were going to use this in
I
geometry.
know they said they never used geometry. Okay, now the issue is I have no right angle, because we know SOHCAHTOA, which involves right triangles. So I'm going to make a right triangle right here. And in fact, not that I didn't just make 1 right triangle, I just made
2.
2 right triangles. The issue is I don't have any angles inside of my right triangle. So if I redraw this a little bit smaller here, here's my first one. I had 115 out here, so my question is, what's the supplement to that angle?
Well, it's whatever 180 minus 115 is.
Yes, and I assumed you had that on
Oh, I
your
think that's
piece of
65
paper.
degrees?
It's 65 degrees. Okay, that's a 5. I always, so 180 minus 115 was 65 degrees, and that's the angle that we have right here, 65.
I just showed up out of nowhere.
Okay? Being annoying. Okay, so this angle down here, we have again another supplementary pair or linear pair. So we have 180 minus 123, which is
57?
57 degrees. Okay, so what do we know about these 2 triangles aside from that? Well, not much, but they do share this side right here. So I'm going to call that side X. So there's an X there, and there's an X there. Let's go back and read our problem because there's some more information we're missing. All right, so we got our angles, and we've got some triangles started. Let's keep reading. Assume the 2 ramps are 855 feet apart. So this little distance right here is 855. Now you're saying, Mrs. Schofield, that doesn't really help me. That's not on either of the 2 triangles you just drew, and it's not. So let's let this side be Y, and now we have that Y right here. But when we look at this triangle, that's the whole distance from here down to the second boat ramp. So how much is that if we start up here and we get to the second
How
boat
about
ramp?
Y plus 855?
How about Y plus 855? Okay. Now, if we keep reading, they want us to find out how far is the boat from the nearest ramp on the shore, which in my case is ramp A. Eventually, I'm going to need this distance. I am looking for D, but not right this second. Okay? All right, so we've got our 2 triangles. Both our triangles share X. So what we want to do is we want to create a ratio, a trig ratio, involving the X that we know both of them contain. Okay? So here's my 65 degrees. This would be my opposite, my adjacent. What shall we use?
Tangent!
Tangent is fabulous. So let's say that the tangent of 65 is going to equal X over Y. Okay?
Okay.
If I wanted to talk about the fact that I know X in both of them, then I could also say that Y times the tangent of 65 is equal to X. And all I did is the exact same thing Mr. Lucky did in his question, which is multiply by that denominator. Okay, let's look at our second triangle. Again, here's my angle 57. It doesn't look like 57, but that's what I wrote. Okay, we have an opposite again. We have an adjacent again. So let's use
Tangent!
tangent. Is it always tangent?
Only when we have opposite and
No,
adjacent.
Exactly. You have to think about the problem you have. All right, so we've got the tangent of 57, and what will that equal?
x over y plus 855.
Y plus 855. And in case you're curious, this is actually a system. And we've already done solving systems this year. Okay, again, I'm going to solve it for x. So now, I've got this whole denominator here. So I'm going to write that like this, y plus 855 times the tangent of 57. And that's going to equal x. Okay? Well, if this thing equals x and that thing equals x, then that thing equals that thing.
So they have to be the same.
They have to be the same because they're both x.
So can we just set them equal to each other?
All right, let's just set them equal to each other. So the rest of this is a whole bunch of algebra stuff.
Just go to a new page.
Yeah, that's what I was thinking.
Then you won't
Okay.
run into that bottom corner that sucks.
All right, so let's fast forward here. And here's the equation that we're going to set equal. We had y plus 855. That was all times the tangent of, I got it, thanks for the help, Mr. Lucky, 57.
I did it with the other one.
And that's going to equal y times the tangent of 65. And I'm going to stop looking at my paper and make my colleague do some work.
What?
What? All right, so we need to solve this for y. So first thing, let's go ahead and distribute over here. So we have y times the tangent of 57 plus 855 times the tangent of 57 equals y times the tangent of 65. What's our variable?
Why?
And where are our variables?
Our variables are on both sides of the equal sign.
That is probably not the good strategy, right? So let's get them together on the same side. I'm going to subtract all that mess over there, and it's going to look like this. 855 times the tangent of 57.
While she's writing all that down and talking to herself,
I am.
make sure you catch on to the fact that we're not using our calculator at all here. We're writing it all down, leaving all of these numbers with tangents in front of it. We're going to use our calculator, but not until we're done.
Why?
Because every time we use our calculator, we'll tend to round off our answers, and every time we round off, we're not going to be accurate anymore. So
Right, so we want to leave all those in there until we absolutely have to pick up the buttons. Okay, I got the y's on the same side, but I can't combine them because one has a tangent of 65 and one has a tangent of 57. Any ideas?
how about factoring?
Oh, I'm so glad you said that. Okay, so we're going to factor out the y, and then we have the tangent of 65 minus the tangent of 57, which we know is just a number, but it's not a very pretty number, so let's just leave it like that. And that's going to equal 855, tangent of 57, and then how can we get the y by itself?
Divide by that big mess in the parentheses.
Okay, so 855, tangent of 57, divided by the big mess in the parentheses.
Tan 65
Okay, I'll write
minus
it.
tan of 57.
Tan 65 degrees minus the tan of 57 degrees equals y. Now you may pick up your buttons. Okay?
I usually pick up the calculator with the buttons, but that's not
I
just
don't.
me.
I just push buttons. What do we get, Mr. Lecky?
We get
Yes?
We get 2,177.461 with some more change after that.
Okay.
But we're going to use that again in a minute.
We are going to use that again in a minute. Let's go back to our picture for just a second here. Okay, so we just found our answer for side y, which is right here, which is great. But it's not what they asked us.
Then why did we solve for
Why
it?
did we solve for it? Remember down here we needed D?
Yep.
D was in this triangle right here, and we had no sides. You can't solve a triangle without an angle and a side, or two sides to solve for an angle. So we needed a side, any side, in this triangle. We found the y side, correct?
Yep.
Okay. So this is this big mess we had. Can I undo that part? There we go. Okay, so that was our answer for y, right?
Yep.
Okay, that big decimal is going to be right here on my side. Okay, now in this right triangle, I have the adjacent. I need D, which is the what?
Hypotenuse.
And what do we do with
Adjacent.
hypotenuse and adjacent?
Cosine.
Okay, so let me make some more room here.
Finally, a different function.
I don't need this anymore.
They still have it on their paper.
That's okay. Okay, so if I do the cosine now of 65, that's going to be adjacent, which was y, over d. And if I want to solve that for d,
D would just be y divided by cosine of 65
yes,
degrees.
it would. Y divided by the cosine of 65 degrees.
Should we pull our calculator out and show them how to do all this?
Sure. Remember,
All right.
our y is going to be all of that. All right, so now that we have our calculator, here's what we're going to do. We're going to take our y expression, which was all this. It was probably the answer button for you. And we're going to divide it. So we had 855 times the tangent of 57. By the way, tangent, there it goes, of 57.
It's just off a little bit.
Let's make sure that you're in degree mode before you try this. And I like to go ahead and do the numerator, and then I'm going to divide by the entire quantity in my denominator. Okay? So we've got the tangent.
Aim to the right side of each button.
I'm trying. Of 65. You push the button. Tangent is 65. Got to close that parenthesis minus the tangent of 57.
I'm just Vanna.
Enter.
Close that.
Okay,
parentheses.
so there's where we got the 2177.461. All right, we need to divide that now. So just hit divided by.
We want to teach you how to store it.
Yeah, just hit divided by.
Divided by.
Cosine is 65. Now, Mr. Leckie just asked me about storing. So in class, remember to ask us about storing. All right, and we get 5152.3. So our distance was 5152. And let's round for the calculus teacher, 313.
Yay!
Yay, 313 what?
Feet.
Feet. What on earth were we measuring? Okay. So, if you are the one driving this boat, you now know that you are approximately 5,000.
Other one.
Oh, thanks. 5,000. There we go. Right there.
That's almost a mile.
Here, look. Thanks. Where's the highlighter?
There.
This distance. Look, I can do this. Right there. To the
Yay.
nearest boat ramp. You're about a mile away, so I hope you have some extra gas. All right, so a couple of things that made this problem a little bit more complicated. The first thing was that we were going from the boat to the shore. That's a little tricky. The ones on the homework are not that bad.
Yep.
Okay, you will have triangles embedded inside of other triangles. So you're going to want to look for a side that they share right here and make sure that that side is involved in both of the original trig expressions, trig equations rather.
Or you
that
might end
write.
up just having to combine two sides like this side too, with y plus 855.
Right. And obviously if we would have given you either the x or the y, this problem would have been significantly easier.
Much easier.
Much easier.
We weren't that nice.
No.
But we did it for you.
We figure we'll give you the hard one that we can show you how to do, and then we'll do the medium to hard ones in class.
Everything else should be a piece of cake.
Okay, so this section is all word problems?
All word problems.
Right. And we're at a wrap for
We're
chapter
done.
4. So
See you in class.
bye. Have a great day.